All right, today we're diving deep into a piece of tech that could be the key to unlocking the future of AI. And no, it's not some new algorithm or a fancy piece of software. It's all about cooling and how a radical new approach might just solve one of the biggest problems holding the AI revolution back.
So let me ask you this. When you think about what could actually stop the incredible progress we're seeing in AI, what comes to mind? Is it the sheer amount of electricity we need, or maybe the limits of how we manufacture these chips? Well, what if it's something way more fundamental?
You guessed it. The answer is just heat. That raw, intense thermal energy that every single one of these powerful chips pumps out. It's the silent enemy that could literally melt the heart of this entire technological leap forward.
And this isn't some far-off problem. We're living in the middle of an AI overheating crisis. You've got these incredible next-gen chips, like NVIDIA's new Blackwell, that are absolute monsters of computation. But all that power comes at a cost, and they're slamming right into what engineers call a thermal wall.
This slide just lays it all out perfectly, doesn't it? On one side, you have AI chip power, which is just a rocket ship going straight up. But on the other side, our cooling capacity is kind of just struggling to keep pace. And this gap, this thermal gap between power and cooling, is quickly becoming the biggest bottleneck in the entire industry. Because the rule is simple. If you can't cool it, you can't run it. Period. So, what's the solution? Well, this is where a company called Allogroove steps in with their new cold plate. Now, it's really important to get this. This isn't just a slightly better heatsink. It is a complete, from the ground up, radical rethink of the fundamental physics of moving heat away from a chip. And the secret sauce is what they call a 3D sintered structure. Just try to picture this. They take 332, yes, 332 layers of material and bond them all together into this super complex, truss-like structure on the inside. It creates what is essentially a superhighway for liquid coolant to flow through.
You know, this analogy just nails it. A normal cold plate, that's your congested single-lane highway. When rush hour hits, when your chip is processing a ton of data, you get a traffic jam. Heat gets backed up. But Allogroove, it's like a massive multi-level subway system. There are tons of different paths for the coolant to take, so it can move a huge amount of heat super fast with almost no traffic jams or resistance.
And here are the actual blueprints for that system. That 332-layer design gives them a flow channel density of 33 channels per centimeter. To put that in perspective, that is 2 to 3 times what you'd normally see. And check this out. It's all diffusion bonded, which means no solder. Solder is just another layer that traps heat, so by getting rid of it, they make the heat transfer even more efficient.
Okay, so the design sounds amazing in theory, but what happens when the rubber meets the road? Let's get to the performance showdown because the numbers are where this story gets really, really interesting. Let's just start with the biggest number on the page, 5.5 kilowatts. I mean, wow. The brand new top-of-the-line NVIDIA B200 GPUs, they generate about 1.2 kilowatts. This one cold plate has enough cooling headroom for the next several generations of chips. That's not just keeping up, that's future-proofing.
Okay, next up, thermal resistance. You can basically think of this as friction for heat. The lower the number, the more effortlessly heat flows away from the chip. Allogroove clocks in at 0.0095. A typical number for this is almost double that. So it's not just handling more heat, it's getting that heat away from the processor way more efficiently. And that incredible efficiency leads us to this number, the coefficient of performance, or COP. All this really means is how much cooling power you get for every watt of energy you spend pumping the liquid. And a COP of nearly 1200? Honestly, that is it's almost off the charts. This chart says it all, right? The average system is down there around 300. Allogroove is way up at 1177. This isn't just an improvement, it's a completely different class of performance. It means you're wasting way, way less energy just to keep your system cool. And now for the main event, the head-to-head. Let's look at the table. Compared to NVIDIA's standard plates, Allogroove has almost double the capacity and up to 6 times lower fluid resistance. Then you've got immersion cooling, right? Where you literally dunk the whole server in liquid. Allogroove hits that same level of thermal performance, but with plain old water in a much simpler system. It is a clear winner on pretty much every front. So, you see the numbers, you see the design. What does this all actually mean for the future? Let's zoom out for a second and think about the ripple effects this kind of innovation has across the whole AI industry. Look, this is so much bigger than just stopping a chip from overheating. It creates a domino effect. Better cooling means more efficient data centers. That means lower costs and less energy wasted. But the biggest thing, it completely smashes through that thermal wall we talked about. It tells chip designers, go ahead, dream bigger, build something even more powerful. We can handle the heat. And this isn't just theory. It's a practical solution. The path to actually using this is really clear. Because the plate has such low resistance, you can use these super efficient high-flow pumps. The funny thing is, the bottleneck then becomes the thermopaste, so using something like liquid metal is a must. You basically design the entire system around high flow, and you unlock all this performance. So let's just quickly recap the big takeaways here. Allogroove essentially doubles the cooling capacity of even the best standard plates out there today. Its totally unique internal structure is a masterclass in moving heat while keeping resistance super low. And most importantly, it's a scalable solution that's ready for the AI chips that haven't even been invented yet. And that brings us to our final question. As these AI chips just keep getting more and more powerful and demanding more and more energy, are innovations like superior cooling just a nice-to-have advantage? Or are they the only thing that can keep this whole AI revolution from quite literally melting down?